Guys, just a quick note, you guys know this event is sponsored by StepsIn. If you're not familiar with StepsIn, it's a phenomenal tool that lets you connect your, it lets you help it lets you help build your GraphQL API by connecting it to different data points, whether it's REST, GraphQL, or other databases. I'm totally butchering this sentence, but that's okay. We're going to move forward. Yanchi, I'd love for you to come on to stage and tell us a little bit more about yourself. And just before we jump into the serverless talk, I'd love to hear just your story and the work that you're doing currently.
Yeah, sure. So like as Navi said, I've been working as an engineer for over 15 years now. A lot of that, I guess most of that has been working with AWS. So I guess I started with my career in the investment banking, but then after a few years there, I moved into gaming, and I was working on, well, I guess Facebook games first, and then when everyone moved away from Facebook games to mobile, I moved along with them as well. So I was in the games industry for quite a number of years. And the last couple of years, I've been really focusing on the serverless technologies. I guess you can think about in terms of AWS. That means Lambda, API Gateway, more recently AppSync as well. Now we are talking about the StepsIn as a GraphQL offering. I'm a big fan of GraphQL as well. My most recent projects have all been using GraphQL, using AWS AppSync and Lambda and DynamDB, all things that you consider as serverless, because having been a backend specialist for all my career, pretty much, I just find there's so many things that you do all the time, and they don't really add a lot of value in terms of what your customer sees, but there's a lot of underlying infrastructure work you spend more time doing than the actual business logic that you want to write, or rather you need to write. So yeah, the last couple of years I've been focusing on serverless because I find that it's kind of the thing I've been looking for a very long time, that helps me deal with all the underlying infrastructure challenges, but lets me focus on the things that really matter to my customer. And so that's the stuff that I want to talk to you about today.
Awesome. Super happy to have you. I think we're ready to get started. Guys, love to hear if you guys are familiar with serverless. So if you can drop some comments in the chat, what brought you in for today's talk? What are you most interested in learning from Yan? I'm really excited. Yeah, definitely. What are some of the things that you guys have been doing in serverless that would be interesting for Yan to know as well?
Yeah, if at some point across, I guess during the talk, if you've got any questions, feel free to put them in the chat. If it's something that I will address later in the talk, then I'll probably just skip through it. But then if there's anything, I guess that I'm not going to talk about in the talk, then I'm happy to cover them as well.
Awesome. Ready when you are.
All right. Okay. So in that case, let me just share my screen. And then let me start my slides. Let me know when you can see my slides. Cool. All right. So so this talk is titled Serverless Superpower for front-end developers. So I guess my personal journey with serverless probably started a couple of years ago. So in 2016, I joined the social network startup, and we were building something like a mix of Instagram, Twitter, and Facebook. And we were still fairly small at the time, but we managed to get about 1 million users, and some of them were people from the Instagram and other social networks. And we had this lady who was on the social network at the time. She was one of our biggest users, and many other people like her would run campaigns on our platform. So for example, one time Emily said, hey guys, please vote on this post, and she will announce a winner for this designer handbag she was giving out at 10 o'clock UK time. So I can imagine what happened. So we were watching the traffic pretty much the whole time, and nothing happened during the day. And then at almost exactly 10 o'clock, you got this crazy spike in traffic. I think about 70 to 80 to 100 times your normal traffic without I guess at that point, because it's still quite a small social network. And the thing is that when you are thinking about the capacity planning, all of that on the back end for APIs, these sort of spikes are really difficult to deal with. And we keep running into problems with this because the system just couldn't scale fast enough. And you're waiting for virtual machines to come up. It takes a few minutes, and by the time your virtual machines are available, most of the people has come into the app, try to see if they want Emily's handbag, had a really bad experience, and then left because your capacity just couldn't keep up with the traffic, at least couldn't scale fast enough. And we also had lots of problems in terms of the app. Just every time you want to update it, the backend, you have to require a full downtime. We have to take the whole thing down and then back up, and that whole process takes about 30 minutes. Which, I mean, this was 2016, but still, it's just not what you would consider as good in modern applications. And features was taking months to deliver. Even something what seems as simple changes, so it would take quite a long time to deliver. And all of this was really unsatisfying for everyone involved, from the product team to the developers. And one of the things that I really love about Dan North, and it's one of the things that he said in the past, is that the lead time to someone saying thank you is the only reputational metric that matters. So doesn't matter what you do, if the lead time for someone being able to say thank you because you've delivered some value, that's the only thing that really matters. And it's a message that's really resonated with me and has stuck with me ever since I heard that phrase from him. So on this particular project, over the course of 6 months, we as a small backend team with 6 people, we fixed all the scalability and performance issues we had with the system that we inherited, which is one pretty big monolithic application. And the time that and the time it took to develop new features was drastically improved as well. And the way we approached it was what you would call using an approach that you may consider, you may hear people call the strangler pattern, whereby every time we work on a new feature or we have to touch some of the existing features, we will make a decision whether or not to re-architect it using serverless components. And we'll gradually move things over from the legacy system to this new serverless world. And the stuff on the right may seem more complex, but all the different relationships and dependencies, they already existed in the application before. It's just that when you're working with a monolith, you don't see those when you're looking at them at the architecture level. But when you're working with a serverless components, a lot of the underlying or hidden complexities gets the surface to the architecture level. So in terms of cost, it was never one of our, I guess, objectives or goals for doing this work. The motivation for moving to serverless was to improve the user experience and to improve our agility. But we still found a really healthy dose of cost savings compared to what we were paying for the same system, for the same sort of, I guess, the number of users on EC2. The big win for us was the fact that we were able to go much, much faster. Typical, I guess, feature velocity went from taking weeks or months to days and sometimes even hours to deliver a new feature. So that was 2016. A lot of the tooling, a lot of the, I guess, the developer experience, the problem that we had back then has now been fixed. And more recently, I worked for a different client, also a social network client, and we built a new system in just a few weeks, just pretty much on my own. I built the entire backend for the first version that we went to MVP with for this social network in just a couple of weeks myself, using I guess technologies that you may be familiar with nowadays in terms of GraphQL, and we're using Lambda for the compute, using DynamoDB for a lot of the database data storage, using AppSync as the manage the GraphQL layer, and we use Algolia for search. So as I mentioned before, I've been working as an engineer for over 15 years now, and at least 10 of those years has been working with AWS, as in building things running on AWS. So I'm an AWS Service hero and the independent consultant. And the example I talked about before was the social network that I migrated back in 2016. And nowadays, I spend half of my time working with Lumigo as a developer advocate. And Lumigo is a troubleshooting platform for serverless applications. So you give you a way to really easily see what your application is doing, especially when you're building more and more complex and interesting serverless applications, so that you can see where what's happening, so that the one thing happens here that triggers some event happening somewhere else. You write something to the database that triggers something else that's happening, and so on. And then when it comes to I guess figuring out what's actually going on, you have all this usual built-in alerting and tracing, all of that to make it a lot easier for you to find out when you have a problem. The other half of my time, I work as an independent consultant, where I help other companies adopt serverless through trainings, through consulting, and also sometimes working with the client to actually build and deliver an MVP project for them. In the spare times, I also written a couple of books with Manning and published a few things with them. And I have also self-published a video course called the AppSync Masterclass. So you can go check it out at the appsyncmasterclass.com. And I also do a weekly podcast called The Real World Serverless, where I talk with other people who are also building and running things with serverless components in production. So I guess my journey with the cloud and AWS started in the 2010 when I was making Facebook games at a company called GameSys. Everything was Facebook games was all the rage at the time. You got games like Farmville had something like 250 million daily active users. I mean, we were working on games that's a lot smaller, but we still had over 1 million daily active users on our systems. And then I think it was 2013 timeframe when everyone kind of just left Facebook and start playing games on their mobile phones. So we kind of did the same thing as well. And I think that really changed for me in terms of going from, I guess, banking to these social games, is that you're now dealing with users that are distributed all around the world. So your system have to be running 24/7. 365 days a year. And you're talking about systems that have to handle millions and millions of unique users potentially every day. And this is where like the cloud is why the cloud is so appealing, because of what you get in terms of the scalability that comes out of the box, in terms of having the ability to build systems that are running on multiple data centers in different regions, so that you got great resilience and systems that are more secure than ever before. And then you also have a system that the fact that you can build things much quicker now, because the more and more you can just delegate a lot of the, I guess, the underlying, the undifferentiated infrastructure work to the cloud and focus on the things that actually matter to your customers, so that you can iterate against the market very, very quickly. That being said, AWS gives you, and other cloud providers gives you basic building blocks, but to build your actual application, to build your masterpiece, you still have to do a lot of work yourself to take all the different pieces and then combine them together in a way that delivers your desired outcome. And a lot of that involves setting up, I guess, the networking for your application. Well, when it comes to networking in AWS, that's network security. That's just a lot of things you got to do. Sometimes, even for me, who's been working with AWS for over 10 years, it feels like every time you need to debug some network issue, it feels like you have to go through a university degree again, just to understand what else is actually going on. And then you got to worry about the virtual machines themselves, apply security updates to your machine images, install dependencies you have for your application, and then the setting up auto scaling, making sure you've got the right capacity in the different data centers, so that if one goes down, your application doesn't go down with it, setting up load balancer and logging agents, and there's a whole bunch of things you've got to do in terms of maintaining the virtual machines themselves. And then you start thinking about your actual application layer, setting up your web server. It could be Express app, it could be Fastly, or whatever the flavor of the month is, configuring all those security or authentic authorization and authentication, middlewares and whatnot. And then you start writing your application code. The actual business logic that, well, quite frankly, is the only thing that your customer cares about. And it's probably the only thing that you should care about. But there's just a lot of things you got to do to get to the point where you can even start writing those business logic. And most of those things are what I would call yak shaving, the things that you have to do to get to the point where you can do the things that you need to do. And it's all terribly, terribly distracting. And I've always wondered why I can't just, write the business logic and have someone else deal with all of this other stuff for me. I don't want to do them myself, but at the same time, those are also things that are crucially important. They're absolutely essential to set me up for success. And just because you can spin up a web server and in 5 minutes, it doesn't mean that you have a production-ready environment. And whenever I hear people say, well, we got an application that's got, I don't know, 100 users or whatever, so we're not going to need all of that fancy stuff you talk about in terms of auto scaling and having different availability zones and all this other stuff. And whenever I hear that, I just hear that, well, you've kind of just admitted that you're never going to be successful. And if you never think, if you don't think you're ever going to make it, then what's the point of doing any of this in the first place? I imagine if you and your team works very hard to build this viable product, and finally you found your market fit and you finally got some traction, and instead of celebrating and I don't know, getting ready to buy a new house or a new Tesla, your collective dreams and hopes just dies with your puny little server that you've got running your application because it just can't handle the load. And this happens way more often than I like to see. Some of my customers has come to me in the past because of they've experienced this very thing themselves. And one of the lessons I've learned in my time working with all this in the gaming industry is that it's hard to predict when you're going to be successful. You've got lots of different ideas, but you never know when, which one's going to take off. But you should always prepare for success because you work very hard for years and years. And then when you finally found something, the last thing you want is for you to find yourself not prepared for what success means for your application. And you may think, well, doesn't Docker just kind of solve that problem, right? In theory, that once you finish your code, you've tested it and it runs on your machine locally inside a Docker container, you should be able to just deploy it to production easily. At least that's what the promise, what the containers promises you. But again, to actually do it well and to actually do something that is going to be scalable, that's resilient to the all kind of problems that you're going to run into in production, you still have a lot of complexity you've got to deal with in terms of how you schedule the containers onto the available virtual machines that you have running, and to actually manage and scale the underlying, say, EC2 cluster, and to provide the multi-AZ redundancy and so on. And to really do it well, you still need some help, and that comes in the shape of tools like Kubernetes or Mesos or ECS. And I guess right now, Kubernetes is kind of the clear market leader in that particular space. And you're probably going to need something else as well, like a Terraform to help you do infrastructure as code. And then you need something like Vault to manage your credentials and encrypting secrets and so on. And then there's all this other stuff you need around your application, like circuit breakers, like service discovery, so that you can route requests to the right container. And you also need things like service meshes like Linkerd or Istio for those things. So really, in reality, to get all of that up and running and set up correctly and secure to be actually ready for production workload is still going to take quite a long time. And of the companies that I know who's sort of gone down this route and has gone all the way through to production, it seems to take them at least 12 months to get to the point where they have productionized their first Kubernetes application. With some of the managed Kubernetes offerings you see nowadays, this is a lot better. But I still find that with all these different tools you're going to have to use, there's still a very steep learning curve, and there's a lot of tinkering you have to do. There's a lot of different things you got a configuration. How to pronounce it's pronounced Kubernetes. I don't know if that helps. And you got to do all of this just to ship a piece of JavaScript code. And it creates a lot of technologies, a lot of things that I have to own, a lot of things that I have to learn and manage and myself. And again, these are all things that I got to do so that I can get to doing the things that I actually need to do, which is probably just shipping some couple of lines of JavaScript code to implement some feature that my customer wants. which is crazy. I find just so destructive, and there's just so much things you got to do, and you see teams spend weeks and months and maybe longer just on tinkering with all the different configurations that of things that you got to do with all these different tools you have. But that being said, increasingly we are dealing with systems that has to do with large number of users, and the users that are distributed globally. So we got systems that are, they have to run 24/7. And to tackle the complexities that comes with these requirements and new demands, our systems, they do need to be more complex, right? Which is why we do have all these very complex and sophisticated tools to let us do that. At the same time, our brains haven't got any bigger. Unfortunately, biology just doesn't quite evolve at the same pace as technology. So, I mean, how do we cope with all these increasing complexities that we are dealing with as we're building bigger and bigger, more interesting systems with the same limited amount of cognitive capacity that we have? And I think the trick is that you've got to have to just, use the leverages that lets you do more with less. When we moving our applications just as it is into the cloud, we're running them on virtual machines or on containers. Ultimately, we are still managing infrastructure. I mean, we've got better tools to do that nowadays, which is great, but it's still something that we've got to manage ourselves. And the infrastructure, the pieces that we have to work with are also more capable. But again, they are still our responsibilities, regardless how much easier it is to manage them and to deal with them than used to when we have all these servers we've got to manage and maintain in the private data centers. And I think this quote from Matt Klein, who's an engineer at Lyft and one of the creators for the Envoy project, it really captures the essence of the problem here, that unless you're an infrastructure company, infrastructure is basically overhead. And the amount of time and energy you spend on dealing with infrastructure is time and energy that you could have spent on differentiating your product instead. So really, you should be leveraging your cloud provider and get them to manage as much infrastructure for you as you possibly can. And so that you can focus on the things that actually makes a difference to your customers, things that are actually important to your business. So that you can enjoy yourself. I don't know. I guess now is probably not the right time to talk about on hopping a holiday anymore. But at least you can you can enjoy yourself doing other things. So when it comes to serverless, what I really mean is any technology. It doesn't have to be functions as service or Lambda. I mean any technology whereby you don't have to worry about scaling. You don't have to worry about provisioning and managing servers. And that means things like the network configurations. That means things like what security patch you have installed, and what is and the things like what dependencies you have installed on those machines, like curl and other things like that. And ideally, you don't pay for them if nobody's using your system. So if you have, I guess, environments like your dev environments where there's no traffic most of the time, you shouldn't have to pay for those environments just because you've got a server running there 24/7. So as I guess ever since AWS released the Lambda service in 2014, serverless became a thing and became something that we can talk about. And every time I say serverless, there's always someone reminds me that there's still servers somewhere, which of course is terribly missing the point. And I think Goiko says it best when he says that serverless is serverless in the same way that Wi-Fi is wireless. Because even when you've got Wi-Fi, you still have routers, right? You still have cables that goes into the routers. But when you're using a Wi-Fi connection, you don't think about them because those cables are no longer your concern. It's no longer your problem. And serverless is exactly the same. It's exactly the same thing. Even though your code is still running on some server, but the management and provisioning and scaling of those servers are no longer your concern. And this is where you also hear people talk about function as a service, and which is, I guess, where you'll find things like AWS Lambda or Azure Functions or Google Cloud Functions and so on, where you literally just write a piece of function code and then you upload it to the cloud, and then you say, hey, my cloud provider, please call my function whenever something happens, which could be some user hitting your HTTP API. It could be an IoT device sending a message, some, I don't know, recording some sensory data every now and then. It could be your application receiving some event from somewhere. It could be a cron job that runs every 5 minutes. Whatever that the case, you can say, hey, please call my function when this thing happens. So why is this so good? Why are so many people so into serverless or so excited by what you can do with serverless technologies? Well, for starters, you get a lot of scalability out of the box. You don't have to wait for virtual machines to spin up, which typically takes a few minutes. And when you need to scale up, you can tap into a massive pool of managed EC2 instances that the Lambda team is managing for you. But when your application is not seeing any traffic, it also scales down to 0 as well. And companies like iRobot is running 100% serverless for quite a number of years now. And as you can imagine, being iRobot, they're absolutely running at a really big scale. And even then, Ben Cahill, who's one of the what do you call them, cloud scientists at the iRobot. They manage the backend infrastructures, the service architectures at iRobot. Talks about how every year around Christmas and Black Friday they got millions of new robots coming online, but for them it's just business as usual. It's almost like a non-event for them, even though they are experiencing massive spikes in traffic. And they got companies like Basel, who's a news site in the US. They're serving 80, I think over 80 million monthly active users. And again, they're fully serverless as well. And you find many companies, many household names that are all using serverless in a very big way. Another reason why people are excited about serverless is that, well, it's just oftentimes being a lot cheaper when you don't have to pay for servers that are sitting there doing nothing. Of course, the caveat here is that if you are dealing with a system that has got a really consistent, really high throughput, then maybe it's going to be more expensive to run your application on serverless compared to running a bunch of containers or servers yourself. But for most applications, you will find that you save a lot of money just because from your infrastructure cost, just because you have a lot of spare capacity sitting there doing nothing a lot of the time. Even companies like FINRA, who's the financial regulator in the US, found that when by using AWS Lambda, they were able to increase their cost efficiency by a factor of 2. And when using serverless technologies like Lambda, API Gateway, AppSync, DynamDB, and so on, you also get a lot of redundancy out of the box, where your code is automatically shipped to 3 different data centers or availability zones out of the box without you having to do that work yourself. And also, you're not paying for that extra redundancy by having additional machines running in different data centers that are not being fully utilized. And of course, by letting the cloud provider take care of the security of the operating system as well as the networking around it, and well, they can typically do a much better job than most of us can. For example, when the Spectre and meltdown happened, I guess that was 18, maybe 2 years ago. I remember very clearly that when the patch was announced, I spent maybe like a week working with my colleagues at the time to patch all the different machine images we had and Docker images we had. And then I didn't even think about Lambda until I saw a tweet from Chris Munce, who runs the developer advocate teams at the AWS for Lambda, that all the virtual machines running Lambda has been patched for Spectre and meltdown. Then it hit me that, well, we have got all these different Lambda functions running in our environment, which we didn't even think about. It's because, again, it's security that's provided by the cloud provider. But the big thing for me is that when using serverless components, I don't have to worry about the infrastructure, which means that I can focus more of my time on building the actual business logic, the features that my customers want. So it gives me a lot of velocity in terms of taking an idea and putting it into production and then start testing the idea against the market. Although a lot of things that I typically have to do in terms of I guess running application on virtual machines or on containers, things like setting up machine images, configuring load balancers, and all of these things just becomes either irrelevant or they've been drastically simplified when I'm using serverless components. And the other sort of, I guess, the other ingredient to a successful team you need, or at least a successful project, is having good people, people with the right skill sets in your team. And this is where you hear a lot about, full stack developers, which I think most of us aren't really that full stack. Truly full stack developers, I think, is super rare and very expensive to find and to keep in your team. Because when you look at the actual disciplines of front-end development versus back-end development, there's actually a lot of depth and the width to both of those things. And what you find in a lot of the full stack developers is that maybe you are really strong on front-end development, but you know just enough to work on the back-end code if you need be, or if you're more like me, that you've spent most of your career working on the back-end, so you know a lot about all the different concerns and that you need to deal with on the back-end, but you probably know just about enough to be able to work on the front-end project, but you're no way as equally strong on both sides of the fence. And for a lot of the front end teams, the things you're gonna have to learn to get to the point you're actually comfortable and competent enough to build something that is production ready and running on AWS and can scale to your application as your application continue to grow and hopefully be successful. There's just a lot of things you're going to learn, which is kind of like if you have to, I don't know, build a toaster from scratch by assembling all the raw components from the raw materials. It's just kind of like that, because you got to do a lot of the groundwork in terms of setting up the networking, which, like I said, feels like sometimes you have to take a whole university degree just to be able to know what you're doing. And then setting up virtual machines and all this other stuff, versus when using serverless components like Lambda or API Gateway, you just kind of like using a toaster. It's almost like cheating, but you got to focus on just having a toast and eating it, and instead of making a toaster yourself. So for front-end focused teams, this can, I think, often find that this can help them delay the point at which they need to have more of a backend specialist in the team, and so that they can. And so that you can focus more on the things that are important for your customers, which is more the sort of the UI and the user experience, and really polish that, rather than worrying about having to have someone take care of all the DevOps requirements you have to automate things and so on. And when you are a backend engineer like myself, it also means that you can get a lot more things done with a lot less effort, and I can't stress this enough, a lot less stress as well. Because when you're responsible for the underlying infrastructure, and believe me, those infrastructure tend to go wrong sometimes at the worst times. For maybe like, I don't know, 8 years of my life, I was on call and sometimes being waken up in the middle of the night at 3 a.m. because 3 a.m. UK time is about peak time in the US, and that's when typically things tend to go wrong. When the infrastructure is managed by the cloud provider, and they can typically do a much better job of making sure that if something goes wrong, the hardware just gets replaced, and there's no impact to your application whatsoever, then that means that I have a lot less stress I got to deal with, which is great, because as I get older, I'm also worse at dealing with the stress nowadays. So when using things like AWS Lambda, SNS, and API Gateway, and so on, you get a lot of those redundancy out of the box, which means I get to focus more of the time and energy and attention that I have on the things that are actually important, and the team can focus more on improving the user experience. Because I think the backend, we got a joke. I guess me and my colleagues, we used to have this joke that the only time people talk about a backend is when it doesn't work. It's like people don't talk about air and breathing, except when you can't breathe. And the backend, I think, should just work, and it shouldn't be that hard. And I think, luckily, when you're using serverless components, that oftentimes they're not that hard to make it work and make them scale. So another recent project I worked on, this is the other social network I talked about at the start. This was, I guess, last year. I did this project with a client. We built a new social network that lets you, as in university students, I guess, register your sporting interest and find other people to do sports with. And we kind of delivered the whole MVP project. At least the initial version of it, in just a couple of weeks, working with 2 other front-end developers who worked on a mobile app, as well as a separate CMS system. And I kind of did the whole backend myself, working I think 2 or 3 days a week over the course of about 4 weeks. And I kind of repeated the whole thing using just a few different services on AWS. We're using S3 to hold all the image assets and videos and so on that people upload, and then we serve them out of CloudFront, which is the CDN service you get out of the box of AWS, so that you get nice edge caching for those static assets. And then for the authentication side of things, we use AWS Cognito. And then when the users are authenticated, they can call our GraphQL API, which is hosted and run in the AWS AppSync, which if there's any complex business logic, we write them and put them into Lambda functions. But a lot of the time, we would just have the GraphQL resolver go straight to DynamoDB. So someone looking for, they are trying to get their profile or get some other user's profile, we just fetch those profile straight from the DynamoDB tables. And sometimes where you got more complicated logic, we put those into Lambda functions instead. But a lot of times, those functions will still talk to the same DynamoDB tables. And for things like search, I'm not a fan of Elasticsearch, and I think there's a service called Algolia, which is probably the closest thing we have to serverless Elasticsearch, which is a lot easier to work with. So we have our functions to call Elasticsearch when we need to input, when we need to do search, when you want to find activities or users near you. And whenever we update things in the DynamoDB tables, we want to make them searchable. We have a DynamoDB stream trigger Lambda function, and then synchronize the data from the table to the Elasticsearch index, the Algolia index. And in terms of some of the business analytics stuff, we also record a lot of them and capture a lot of those BI events using Firehose, which batches those events into files and then put them into S3. And then we can run BI or business intelligence reports against them regularly using Athena. Again, I mean, this is just this not everything that we had. The overall architecture is a bit more involved than this, but in terms of the high-level components and how they fit together, this is kind of what we had. And as soon as we kind of went live, just in time for the semester started last September, we went from pretty much zero to about, I think, 15,000 installs in the first couple of weeks, all organic. And we had we're averaging about, I think, 250,000 API requests per day. And the first 2 months before lockdown started again in Belgium, and then everything kind of went back down again. Our monthly AWS bill was around $60. As you can see, most of that just on the AppSync caching. And considering that we were using about 5% of the cache capacity, so that $31 or whatever we were paying is pretty much flat, even as we grow our traffic by, say, 10x. And I think we were able to achieve about 99% the cache hit rate, which means that most of the traffic was hitting the cache instead of going to the Lambda functions or the DynamoDB tables. In terms of performance, the latency wise was really good. The P99 or the 99 percentile latency was around 500 milliseconds, and for web applications, I think anything, if you can keep your 99 percentile latency below 1 second, that's pretty good. That's good enough, I think, for most web applications. So in terms of for this particular project, we did it really quickly, and we were able to build a system that would be able to scale to millions of users when you get to that point. And we had the system that's basically requires very little maintenance. There's no servers. We had 0 EC2 instances, and all the components we had are serverless, apart from the Elasticsearch, the AppSync caching, which you're paying for uptime. But other than that, everything else is based on the pay as you use. So if no one's using the system, you don't pay for anything. So our dev environments was basically free. All of our dev and test and staging environments were basically free. But for the production environment, apart from the AppSync caching, everything else was also pretty much a scale to 0. So during the downturn, the last couple of months when there's been lockdown in Europe, our system is basically just, there's almost no cost to running our system. Of course, serverless is not right for just about for every use case, or at least not yet. but there's enough of them for me to think that almost everything that you want to do can be done serverlessly nowadays. So if you want to build REST APIs, well, you got API gateway with Lambda and DynamoDB. Very common combination you see for people that are building APIs, web APIs. So that should say the GraphQL APIs, not REST APIs. So for GraphQL APIs, you have AppSync that can basically do the same job. You don't have to run your own GraphQL server and worry about scaling that GraphQL server layer. You can just put your GraphQL in the AppSync, and it can be it can be responsible for managing and parsing those GraphQL requests, and then calling your resolvers to get data from DynamoDB tables, from relational databases, from Elasticsearch, from Lambda functions, and so on. And if you're building anything that's got like a real-time push notification kind of thing, you need the WebSockets. You can do that with API Gateway. You can do that with AppSync. You can do that with IoT Core. All three services support some kind of a push notification via WebSockets. If you want to process a lot of events in real time at the kind of typical big data projects, really common combination is to use Kinesis to sync in all the different events you have, and then you process them in batches using Lambda. And you've got many companies that are doing this at massive scales. I was talking to someone from the national TV station in Finland, and they're processing somewhere in the region of about 500 million events per day using this setup. And if you want to model complex business workflows, there's step functions, and that lets you model your business workflow as a state machine, and the different steps where you want to do something. You can implement your business logic in those steps using Lambda functions, and then delegate to step functions to manage the state of the workflow. And then you can have this visualization layer that you can quickly see, okay, for a particular workflow, what was the path? If you got lots of if else branches, and if something was to go wrong, where did it go wrong? You can very quickly identify those failed workflows and the states that the workflow failed at. If you want to build something that's like really event-driven architecture with lots of different teams who are looking after different subset of your domain, and they interact with each other in a way that's entirely through events, then you can use EventBridge, which can be your centralized event bus that captures events from your application, from your AWS environments, as well as from third-party services, things like Salesforce, things like Auth0 and Zendesk, and so on. And then the trigger events and process them with Lambda functions or other services. If you're doing DevOps and you need to automate a lot of the things around your cloud environment, then you can also do that with EventBridge and Lambda by subscribing to events that are captured by CloudTrail, which collects things that are happening in your AWS account. And then you can also use things like AWS config to configure custom config rules, so that whenever someone is making changes to your AWS services or resources, those rules can be checked. And if there's any violations of those rules, then those will be captured in CloudWatch in the EventBridge, and then you can trigger Lambda functions to automatically remediate those violations. Or if you want to do, or I guess more commonly, you're doing lots of, maybe if you're doing DevOps, you're also doing lots of cron jobs and things like that, which you can also do with EventBridge by setting up a cron expression to run a job every couple of minutes, couple of hours or whatnot, and then use the Lambda function to actually perform the cron job itself. If you're doing Alexa skills, then you can use Alexa. You can write Alexa skills in Lambda functions. If you're doing, I guess, media transcoding, then you can use S3 Lambda function and Elemental Media Convert to basically take care of all of that stuff for you. If you're building IoT applications like iRobot, then you can use the whole suite of the services from AWS for managing your IoT devices, and then use IoT Core to collect events and messages from those IoT devices. And then once again, configure your rules there, and then use Lambda functions to react to those events. So Lambda is serverless components you can pretty much use serverless for almost everything you want to do nowadays. But there are a few places where I would still say, serverless might not be the right choice, mostly based on the non-functional requirements you have in your system. So for example, with Lambda, you have to think about things like cold starts. So, the first time a new worker is spawned up to run your code, there's some additional latency overhead there. So if you got something that has really strict latency requirement, then maybe Lambda is not the best fit. Or maybe you've got applications that are that's very, very spiky in terms of traffic, then you also may run into some scaling limits around Lambda as well. But all in all, in most cases, Lambda is going to be good enough for the vast majority of the applications out there. And when you've got something that is a fairly high throughput, you may also find that, okay, maybe it's more expensive to run stuff on the serverless compared to running a bunch of containers. At that point, it's worth thinking about the total cost of ownership for your application, and not just what you're paying AWS on your monthly infrastructure bill. Because when it comes to total cost of ownership, we have to think more than just the operational cost of the hardware, of the servers and networking and storage and things like that, but also in terms of the engineering cost and the cost of hiring and finding those engineers in the first place, and the cost of equipment and things like that. And when AWS did an analysis, I guess this was 2018. They looked at a lot of the enterprises and how they're using AWS, and they found that in terms of staffing cost, using serverless components give them a massive saving for those large enterprise customers, because, like I said before, by removing a lot of the infrastructure, by removing the burden of having to manage the infrastructures from your engineers, they can focus on things that are of higher value to your business. And it also means that you don't need as many engineers to get the same amount of stuff done. So especially in the sort of enterprise environment, this can mean a huge difference in terms of your staffing cost. But sometimes you do have applications, at least a part of your application, that are running at such a high scale that the infrastructure cost far outweighs the staffing cost. In which case, yeah, absolutely, you probably shouldn't be running stuff in servers in that case, and instead move that part of the application into containers. But which is why most of us who are advocating for serverless components and technologies, we don't say serverless only. We advocate the serverless first. So you start by putting stuff into serverless until you can't, and then you can move them into containers instead. So I've been going on for a bit longer than I thought, but thank you guys so much for your time and attention this evening. If you want to get in touch with me, you can find me at theburningmonk.com. As I mentioned before, I'm a consultant. I help companies adopt serverless components. And I also got a video course called the AppSync Masterclass. So if you want to learn about AppSync, GraphQL, and how to build the scalable GraphQL APIs using serverless technologies, then check it out. But otherwise, thank you very much. And I guess we'll have some time for questions and see if you guys got anything in the chat box. Let's see.
Yeah, and there was a couple of questions that came a little bit earlier on. Claire asked, and I think some of these were touched on in the talk. By the way, that was phenomenal. I think it was, first of all, your slides were awesome. Great images. Claire asked, what are your recommendations for playing with serverless for free?
Yeah, so that's the great thing about the things that I call serverless, like AWS Lambda, API Gateway, DynamDB, and so on, and that the billing model for them is pay per use. So you only pay for requests that your application process, which means by and large, and also with AWS, all of these services have got a free tier. So Lambda lets you, I think you can invoke, I think like 1 million invocations for free a month, which means like for some of my production applications, I don't pay for them still because, don't pay for Lambda functions at least because like the application that I talk about is the second application. The 99% caching hit rate, the cache hit rate means that most of our traffic just gets soaked up by the cache. So our Lambda usage was actually not high enough to start paying for that. So that's beauty of the serverless, that if you don't have the traffic, if you're just playing around with them, there's most likely you're not going to pay for them. You're not going to pay for anything. And I've got lots of toy projects in my AWS account that I don't pay for because of that, because everything falls under the free tier.
Yeah, no, that makes sense. There was another question from Claire. What are the limitations? And again, some of these you've already sort of touched on a little bit. What are the limitations of serverless in your experience?
Yeah, so there's some system limits. For the one thing I sort of touched on is the fact that if you got something that has got really strict latency requirements, so when it comes to with Lambda, it still runs on servers, but these are running. So with Lambda, these are under the hood. So Amazon's got this virtualization layer called, and which is something that they build themselves, called the Firecracker. It's not a container, but it's like a micro container. I guess they call it a micro virtual machine or something like that, a micro VM. But ultimately, it runs on those, something that's sort of virtualized a server environment. So when there's no traffic, everything gets scaled down to 0 for individual functions. But if suddenly you're getting some request, that means the system is going to say, oh, I need to run your code, but then your code is not running anywhere. So I need to create a new virtual micro VM and then load your code, which means initializing the actual runtime environment for Node, and then loading your Node.js modules, and then running your actual handler code that's part of that module. So that first time your functions have to get warmed up, has to be initialized, it takes a bit longer, which means occasionally you're going to see a spike in latency because of that happens, because there's a new micro VM has to be created. So if that's for web applications, you're okay. Occasionally you're going to see some spike in traffic. That's not the end of the world. But there's some application that just can't tolerate that. For example, if you're talking about some high frequency trading application where you kind of need to guarantee sub-millisecond response time all the time, then maybe it's not the right thing for you, because you will see occasionally, based on the traffic pattern, you will see occasional spikes in latency because of the fact that these micro VMs had to be created on demand at some point based on the traffic pattern. So that may not be a good fit. There are other limits around how long a function can run for in one go, which is 15 minutes. So if you got really big, really large ETL jobs, or you need something that's long running, again, that's not a right fit there, because you need to have something that can run for more than 15 minutes at a time. Otherwise, there's also some limits around scaling. There's no upper limit on how many instances of a function you can run at a moment at the same time. You can always just raise that. That's a soft limit. But there's a limit on how quickly you can go from 0 to your peak throughput. So the limit is 3,000. And so if you got systems that are, one example is I used to work for a company called the Zone, which is a big sports streaming platform. And when there's a big football match, I guess what you call soccer, I call football match going on, we will have maybe a couple hundred or maybe a couple thousand concurrent users. And before the match starts, like 30 seconds before the match starts, you will go from about a couple thousand to 1.7 million or something stupid like that. And so if you think that the spike in latency, the spike in the traffic, that you're going to see, that is too steep a climb in terms of traffic that we will hit those limits around scaling around Lambda. That you go from 0 to 3,000, and then you are capped at the 3,000, and you can only go up by 500 more containers, so micro VMs per minute. So to reach, say, 10,000 VMs run VMs running, then that's going to take a few. Was 12,000 divided by 500? That's the 24 minutes to get to the peak throughput you need. So things like that, which means about the things you could do to work around those limits. But by the time you do all of that, you may as well just take that bit of code, the system that need to handle that spike, put into a bunch of containers where you have a more natural way of managing the scaling, because we know when those spikes are going to come, we know when they're going to go away. So we have more, more natural way to control the scaling for the system. So those are probably three big limits around when I probably wouldn't when I wouldn't use Lambda. Besides that, it's just a case of where is economically feasible. So some systems you 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 may find that okay, it's going to cost me $100 a month more to run on serverless than to just move them into containers. But if I don't have the skill set in the team to do that, then I have to then hire somebody else and pay him, I don't know, 5-10 grand a month to actually look after the system for me. So that's where you got to think about the total cost of ownership as opposed to just what's on your AWS bill. But if you're talking about maybe like $20,000 a month difference on the on the cost of your system to run them in AWS, then okay, you know what? Maybe it's better to run them in the containers.
I'm like so blown away at like the amount of knowledge that you have on this stuff, and I think everyone else feels similar to how I'm feeling. That was a very very detailed response, Claire. I hope you were satisfied with that with that answer. There's a couple more questions. I think we might have touched on this one. Do you believe one serverless provider is a clear winner? For example, AWS is better than Azure.
I would say, I guess it probably depends. AWS definitely has got the biggest ecosystem, but what you typically find is that most people just use the same 10 different services. I think there's a lot more things you could do, but again, as you go into more obscure use cases, that you may find that you got needs that are only AWS can offer, or only Azure or Cloud or Google Cloud can offer. But I guess most of the things that you typically need for your application can be found in all the different places, in all different cloud providers. But I guess that the main thing is just what you want, what you are familiar with, probably. So if you're already a Microsoft.NET shop and you're already using Azure for other things, then I guess the natural thing to do would be to use Azure functions. But if you're AWS shop and you've been using AWS for other things already, then it makes sense for you to stick with AWS and use Lambda. There are technical differences between them. There are also scaling and performance differences between them. But I don't think they're that big. I don't think there's any sort of drastic difference between them. But what I would say is that with Azure and with AWS, there's a lot more focus on serverless and functions than there are on the Google. Google Cloud is still very much so I guess doubling down on the Kubernetes side of things, and they haven't really done much with the Google Cloud functions for a while. So I guess that's probably my impression of Google Cloud and where they're going.
Awesome. By the way, Jan, I just want to check in. How are you on time? Because there are a couple of really interesting questions, one from Matt and one from Claire. I just wanted to do a time check.
Yeah, I'm okay to stay on for a bit longer.
Okay. Is everyone else okay? Okay, perfect. So Matt has a question for what resources to look into to get ourselves familiarized with all tools you touched upon, IT, AWS courses, books.
So I guess the AWS is a really big thing. So I'll probably start, if you're brand new to AWS, then I'll probably start with some of the courses you find on cloudguru.com. And they do a lot of certification courses, but no, I probably wouldn't bother with the certification itself, but studying for the certifications are quite a useful way for you to I guess get exposure to lots of different services, at least understand from a high level what different services do and what are the difference between the different services. Like in terms of databases, they got quite a few different options there. When do you use which? In terms of queuing and data streams, there's quite a few different services that can do similar things. What are the differences? How do they overlap? And things like that. That's quite good. In terms of learning about serverless stuff in particular, there's I check out my blog. I write quite a lot of different things over there. There's also Jeremy Daly has got a Off by None newsletter where he collects articles from all over the place, and then I just put them in the chat. And then he sort of does a weekly newsletter with a lot of links that you can go and read about. So he does quite a good job of that. And there's also, I guess, the video courses, and I've done a couple myself, and loads of things like that that you can find. But yeah, it's there is a lot of different things that you can learn. Unfortunately, AWS is such a beast nowadays that there's no end to things to read about. But I think if you're just starting out, then look at some of the certification courses that you find on the Cloud Guru. It's a pretty good place to start.
I like that that spider graph that you showed, kind of like in the middle way of your presentation, how you talked about, what exactly is full stack, and what you should focus on. I think this is a pitfall that a lot of new developers tend to fall under when they think of themselves as a full stack developer. There's a lot to learn. So it's speaking of that, we actually have a panel that's coming up tomorrow, and it's very focused for front end developers on in-demand skills. I would have loved to have you on that panel. Maybe next time.
Maybe next time, yeah.
Maybe next time.
Yeah, I'm not much of a front end developer, by the way. Like I said, I can, if you throw me into a project, I can make it work. But I'm not I'm not very good front end developer.
A serverless panel then.
Okay.
I'm sure I can think of something. But there was a question from Claire. I think she left, but if anyone else is interested in this one, what are your thoughts on vendor lock? Serverless is very powerful, but locks you into, AWS, for example. Yeah,
so actually got the recent couple articles around that. But firstly, I would say like the whole lock-in thing is not lock-in. It's no more lock-in than it is than say something like using Node.js, using JavaScript, using Express. All of those things are things that if you want to change your mind later, it's going to have some cost. There's a moving cost associated with that, right? The worst thing you're going to do, you just have to rewrite your application. That's the absolute worst thing you got to do, right? But it doesn't mean that you can't. You just that means there's a cost associated with that decision to actually move away from it. So it's not lock-in. And secondly, you got to think about the cost of some of these other, or some of the I guess solutions. So if say you go to the other extreme where you want to be cloud agnostic, you want to be able to move your application from one cloud to another, and you run everything in containers. Well, what's the cost of that then? Well, the cost of that is going to be in terms of development. There's more stuff you got to do yourself. So there's a higher cost. You're moving a lot of the costs that you may incur later when you decide to move to upfront, because your development, you got to build all of this tooling. As I mentioned, right, with Kubernetes, it takes a lot of time to set up everything in your environment to get to the point you've got something that is production ready. So you're moving a lot of costs that you may incur later when you decide to move away from AWS to the moment you start building the project, because you're preparing for something that may or may not happen later. So you're moving the cost of the development cost upfront. So it becomes capital cost right up front, but also in terms of the cost of the actual development, because if some of this tooling means that the actual complexity, that means developer have to deal with them every time they're working on a project. It becomes something that becomes a cognitive cost that you have to pay with your team all the time. And I guess the way I like to think about it is that when I buy a new iPhone, I typically pay for, take out the insurance, Apple Care. But at what point does the insurance become so expensive that I might as well just not pay for the insurance, and just when I need to, when my phone breaks, get a new one. I guess that for me, that's kind of my mental model when I think about okay, there's cost of mitigating against there's cost of moving cost. If I go with everything that's with Lambda, with serverless, if I mitigate that, I'm paying, essentially I'm buying insurance. I'm paying something extra to mitigate a potential cost I may incur later. But at what point is the cost of that insurance so expensive, I might as well just say, ignore that. Even when that disaster scenario happens, we need to move our application from AWS entirely to something else, to Google or to Azure, we may have to do a lot more work at that point. Yep. And we pay for that cost at that point, like paying for a new iPhone. But we save ourselves the money that we from insurance that we pay for, because what we buy the insurance, nothing happens for 3 years. That insurance cost is wasted, right? Another thing is like your application, that is the part that is actually not that hard to move. We actually know very well how to encapsulate things so that even if I've done this myself, and I've seen other people do the same thing as well, that you write your code in such a way that it's sufficiently modulated at the code level that if I want to move it into a container or move from container to run into Lambda functions, it's just a matter of some wrapping around different functions, different parts of my application. That's not hard to do. What's actually really difficult to move is everything else. Is the data. Data has gravity. It tends to accumulate. It tends to want to sit where it is. If for example, if you're using any of the managed services that Amazon offers in terms of databases, you're not going to find the exact same thing in the Google. You're not going to find the exact same thing in Azure, which means you can't use any of the high-level services that any of the cloud provides for you, and that's about 90% of the value that they can actually give you. So you end up going to the point where you have to use the least common denominator that sits across all the clouds, which just using them as a place to get virtual machines from. And then you do everything yourself, including running on database, on containers and whatnot, and including all the infrastructure and all the security and other concerns that comes with doing that. And still, when it comes to that, the data is still going to be quite hard to move because you need to have systems that are 24/7, and you have to move them from one place to the other while keeping the system up and running. So there's still a lot of complexity you've got to deal with anyway. And I guess the biggest thing I would say is that if I find 100 companies and ask them what's the biggest challenge they have, 0 of them would say it's about the mobility and going from one cloud provider to another. 100% of them, but maybe 90% of them would say that it's about agility, wanting to move faster. It's about being more competitive because they want to release features earlier and faster and better than their competitors. Some of them may say it's about security. Some of them may say it's about scalability, depending on what the specific problem that they have burning down their houses. But nobody ever says to me that the biggest challenge they face as a company, as a business, is mobility, is being able to move from one cloud provider to another. And yet you keep finding decision makers in a technical level, for some reason, thinking that's the most important thing, that they are throwing away all these other advantages that they could have and putting themselves into a really bad competitive place by prioritizing mobility above all else. And that's something that I never understood. But yeah, this the whole vendor locking thing happens every time. It happens all the time, but it's all driven by interest groups that has got a vested interest in people staying with where they are. If you look at companies that are talking about vendor locking all the time, you're talking about companies that are basically providing container solutions. Companies that are saying, oh, we can give you private cloud solutions. And guess what? Locking is not just about technology, it's also about skill sets. You see companies going with private cloud providers that are locking themselves into not necessarily a Docker. Well, I guess they are. You're locking into Docker, a specific platform, but you're also locking yourself into a specific provider that can provide you with the skill set you need to run that private cloud for you. Kind of long-winded answer to that.
No, it's really, it's your insights are really fascinating. And I know that a lot of our developers in Mintbean are fairly new to their journey, but it's always so nice to understand the thought process that goes into the decision making of developers much later in their journey of what decision makers are thinking about when they build these complex infrastructures. So yeah, no, your answers are pretty phenomenal. Love the fact that you shared all this with us. Guys, I think that's pretty much it from the chat in terms of questions. Yeah, if anyone else has any feedback or comments that they want to share with Jan, maybe we'll be here for a couple more minutes. Feel free to jump in the conversation.
Yeah, I just put a link to an article that I wrote that kind of summarizes some of the points I mentioned just now about the vendor lock-in.
I will share this with Claire, definitely. So she'll appreciate that. Again, Jan, I truly, truly, truly appreciate the time that you spent with us, and
No
thank you
worries.
for taking the extra time to answer these questions. Really, a lot of insightful information today. So thank you so much.
Nice to be here. Thank you.